So one of the things you're going to have to be able to do this year is to do math without a calculator. When you take the AP Physics exam in May, they aren't going to let you use a calculator on the multiple choice portion of the test. And you have to do 70 multiple choice questions in 90 minutes. Since you don't get a calculator or a reference table, you have to work fairly quickly. Now, I have my own little shorthand technique that I use to solve math problems without a calculator, and I want to show you what I do. Everybody's got their own little way of doing it. This is my own little way of doing it. I basically have 3 or 4 steps that I follow. The first step I take is to make sure that all my numbers are written in scientific notation. So if you take a look at example 1, you'll see the numbers are already in scientific notation. So I don't have to worry about that part. The second thing that I like to do is to round my numbers. If I don't have a calculator, I don't want to deal with decimal points. That includes pi. Do not tell your math teacher this. But if I have to use pi, I use 3. I don't use 3.14 or some infinite number of decimals. I just use 3. Okay, don't do that in math class. However, here I'm going to round my numbers. So I have 5.678, and I'm going to round that to make it 6. Now, I didn't move the decimal point at all to round that, so that does not affect the original power of 10 that I have. So I'm going to leave that times 10 to the 7. If I had moved my decimal place, it would affect the power of 10, and I would have to change that too. And I'm going to write this, the other thing I'm going to do is I'm going to write this in fraction form. I find it really easy to work with fractions when I'm doing math problems and I have to do a lot of steps. I'll get the decimal answer once I'm all done. Now, I'm also going to round 3.218, and I'm going to round that to 3. Again, I didn't mess with the decimal point, so I can leave this in the same power of 10 it started out as. So that's the second step. The first step, make sure everything's in scientific notation. The second step is to round things to a whole number, and I like single-digit whole numbers, which we'll talk about with example 2. The third step is to actually do the multiplication or division. In this case, I'm going to ignore the powers of 10 for now, and I have 6 divided by 3, which is easy. 6 divided by 3 is 2. I can do that without a calculator. Then I have my powers of 10 that I have to deal with. Since I'm dividing powers of 10, whenever I divide the powers of 10, I subtract the exponents. So 10 to the 7 divided by 10 to the 3 becomes 10 to the 7 minus 3, which is 4. And that's my answer. And when I go to look at the choices on my multiple choice test, I'm not going to worry about this number right here because it's not exactly the number it should be. I rounded this number up, I rounded this number down, and then I did my division. So I know that it's not exactly 2. I do know, though, that it is 10 to the 4, that it's 2 times 10 to the 4, or 3 times 10 to the 4, or 1 times 10 to the 4. It's going to be somewhere in there, but the correct part of 10 is 10 to the 4. So I'm going to look at my answer choices and find the one that says 10 to the 4, and I'm not going to worry about that number there. And when I go ahead and do this on my calculator, the number comes out to be 17,644. If I write that in scientific notation, I write it with a number that's between 1 and 10, so 1.7644. I moved my decimal point from here 1, 2, 3, 4 places to the left, so my exponent came out to be positive 4. I went to the left, so it's a positive exponent. Okay, now looking at this number, I can see if I just worry about that power of 10, I'm going to get the correct answer. And notice 1.76, if I ignore all this stuff, that would round to 1.8. 1.8 rounds up to 2. These are really, in the world of physics, the same number. Now, if I was doing an engineering project and designing a bridge that people had to drive across, I would use my calculator and I wouldn't round quite so much. Accuracy and precision matter sometimes. Okay, now, let me just add this parentheses here because that's driving me crazy. Now, In example 2, again, all my numbers are already written in scientific notation, but I can tell you when I look at this problem, I think that's ugly scientific notation. First of all, I want all my numbers to be single-digit whole numbers. None of these are single-digit whole numbers, so I'm going to pretty them up a little bit. I'm going to just start with this number right here, 0.0077. I'm going to make that a number between 1 and 10. So I'm moving the decimal 3 places to the right. So this is going to become 7.7. I moved the decimal 3 places to the right, so that makes it -3. Now, so I just changed that number to something that was equivalent. It already originally had a power of 10, so I need to still multiply that by 10 to the -3. And when I have something that's just in a power of 10, I always assume that it's 1 times 10 to the -3, because most of us like to have a number there to multiply. So if I put a 1 in front of that, it doesn't affect that number in any way, shape, or form. Now here I have 40 times 10 to the 6. Again, 40 is not that bad. It's a nice even number. The problem is it's got 2 digits. I just want to deal with 1. So I'm going to move the decimal. I'm going to make this 4 times 10 to the 1, because I moved the decimal 1 point to the left, so that's +1. It already had a 10 to the 6, so I'm going to make that times 1 times 10 to the 6. Okay, so I've made all those prettier scientific notation numbers. I'm going to do the same thing with the bottom. I don't want to divide something by 300 without a calculator. I want to divide it by 3. So I have 3 times 10 to the 2. I move the decimal from here 2 places to the left, so that's +2. Put in my parentheses. It originally had a 10 to the 6, so that becomes 1 times 10 to the 6. Okay, so that's my first step. Pretty up the scientific notation. The second step, remember, is to get rid of the decimals. So 7.7 is going to become 8. Now I'm going to, just looking at the numerator, I'm going to do the numerator first and then the denominator. I'm going to multiply the numbers. I have 8 times 1, which is 8, times 4, which is 32, times 1, which is 32. So this becomes 32. Then when I'm multiplying exponents, I add the exponents. -3 plus -3 gives me -6, plus 1 gives me -5, plus 6 gives me -1. Oops, excuse me, +1. +1. Okay, and then I'm going to take a look at this. I have 3 times 1, so that's 3. Then I have 10 to the 2 times 10 to the 6, so I add exponents when I multiply. 2 plus 6 is 8. Okay, now 32 divided by 3, that doesn't divide evenly. So what I'm going to do is I'm going to make this 33. Because 33 divides evenly by 3, that gives me 11. I already rounded, so what's a little bit more rounding? Or actually, yeah, I just rounded a little bit here, so a little bit more rounding isn't going to kill me. Now I have my exponents. When I'm dividing exponents, I subtract. 1 minus 8 gives me -7. So my answer is 11 times 10 to the -7. And when I look at my multiple choice answers, that might not be there. And I have to be careful because this is a number bigger than 10. So if I want to write this correctly in scientific notation, I'm going to make this 1.1, and I move the decimal, so that affects the power of 10. I moved it to the left, so this is going to become +1. I moved it 1 space, so my exponent is 1. I moved it to the left, so it's positive. It was already times 10 to the -7, so I'm going to keep that and just put a 1 times 10 to the -7. So I have 1.1 times 1, 1.1. And then I have 10 to the 1 times 10 to the -7. When I multiply, I add exponents. So 1 plus -7 gives me -6. So my answer is 1.1 times 10 to the negative 6. So I'm going to look at my multiple choice for one of the choices that is times 10 to the negative 6. Or maybe they have times 10 to the negative 7 with 2 digits in front of it. Okay, this number and this number are the same number. This is an easy way to convert from one power of 10 to another power of 10 to find a number that's equivalent to it, but just written in a different power of 10. Okay, take a look at number 3. Try number 3. This would be a good place to pause the video and test it out, see what you get for an answer, and then restart the video. So I'm going to assume you restarted the video. All my numbers are written in scientific notation. I don't have to do any rounding, it's already nicely rounded. So I'm just going to do the math. I'm going to start with all the stuff in the numerator. 2 times 6 is 12. I'm multiplying exponents, so that means I add them. So I have 3 plus negative 2, which gives me 1. And then 4 times 10 to the 8. Okay, so this is a nice simple thing. Now I just ignore the powers of 10 and just do the math. 12 divided by 4, which gives me 3. And I have 10 to the 1 divided by 10 to the 8th, so I subtract the exponents. 1 minus 8 gives me negative 7. So my answer is 3 times 10 to the negative 7. Which is exactly what I would get on my calculator if I did it. Now, try example number 4. You're going to have to pretty this one up a little bit. Pause the video, try the math, get an answer, and restart the video. Okay, so I'm assuming you have an answer in front of you. Let's see how your answer compares to mine. So I'm going to start with that 3,000. I want to pretty that up. I want a single-digit whole number. So I'm going to do 3 times 10 to the 3, because I moved the decimal 3 places to the left. It was originally 10 to the 14, so this is 1 times 10 to the negative 14. Negative 14. And then I have 0.0008, so I'm going to make that 8 times 10, and I move this 1, 2, 3, 4 places to the right, so that makes that negative. Then I have 0.002, which I'm going to make 2 times 10 to the negative 3. Oh, so much trouble getting those negatives. 1, 2, 3 to get to that number. It was originally 10 to the 5, so 1 times 10 to the 5. And then 200, I'm going to just put 2 times 10, and I would have to move the decimal 2 places to the left to go from 200 to 2. Now I'm going to do the math in the numerator and the math in the denominator. So in the numerator I have 3 times 1 times 8, which is 24. I'm multiplying these, so I'm going to add the exponents. 3 plus negative 14 is negative 11, plus negative 4 is negative 15. Now I'm going to do the math in the denominator. 2 times 1 times 2 is 4. Again, I'm multiplying, so I have negative 3 plus 5, so that's 2 plus 2 is 4. Now I have 24 divided by 4, so that's 6. Now I'm dividing powers of 10, so I subtract the exponents. Negative 15 minus negative 4. So I have negative 15 minus positive 4, excuse me. I get negative 19. Gotta read that correctly. Those are the easy mistakes to make, those kinds of mistakes. And I get 6 times 10 to the negative 19. And that's exactly what I got when I did it on my calculator also. So that's a quick, simple way to do math without a calculator. Put all your numbers in scientific notation, pretty up the ones that are already written in scientific notation if you have to. Then round everything so you have a single digit whole number. then do your multiplication and division, and then if you're dividing exponents, you subtract them. If you're multiplying exponents, you add them.